Okay, today we're going to skip that warm-up for sake of time. You can see your vocabulary in the middle of the page. I have rate of change and slope, as well as calculating slope. Rate of change and slope mean the same thing. Okay, slope is rate of change. And rate of change is slope. We just had vocabulary like that yesterday. Do you remember how x-intercept meant 0 and 0 meant x-intercept? Okay, kind of got the same thing going on. I want you to know that slope means the steepness of a line. So for example, where we live here in Genoa, Curtis, Clay Center, Williston, Martin, wherever it is that you live around here, what is the slope of our land? We have flat land, would you agree? The slope of our land is very low. It is flat farmland out there, would you agree? Okay, so if we did the slope of our land, it would be very little. Okay, now what if you go to Maumee Bay on the sled hill? Big slope on that sled hill, would you agree? How about the roller coasters at Cedar Point? Big slope, right? Bigger the slope, the better the coaster. Fair enough? Okay. To calculate slope, which is what we're going to do today, you need 2 points. Remember, points are also called ordered pairs. Folks, what variable comes first in an ordered pair? X, and then what comes after X in an ordered pair? Y. X comma Y, right? So we've got to have 2 points. Good news is, if you have a graph, it's very easy. You are just going to count the rise over the run. And that probably is a familiar phrase to you, rise over run. Okay. So you'll notice here in number 1, 2, and 3, I have graphs, don't I? I told you had to have 2 points, didn't I? Do you see the 2 points that are already on your graph? Okay, the question is, which point am I going to start at, the left or the right? Do we read left to right or right to left? So I am going to start at the left point, and I want to get to the right point. My first question is, how many do I have to rise? If I want to go from here to there, I have to rise 1, 2, 3, but I'm not really rising, am I? Aren't I going down? So that's going to be -3. Everybody understand that okay? How many do I have to run? 1. So that will be -3 over 1. What is -3 over 1? It's the rate of change. Does this simplify down to something? Guys, got your calculators? What's -3 over 1? Come on now, it's over 1. -3. How we doing, folks? Let's try again. Number 2, another graph. Which point am I going to start at, the left or the right? The left, which is right here. How many do I have to rise to get to my next point? Everybody agree with 4? And it's positive because I'm going up. How many do I have to run? How's everybody doing? In your calculator, put in 4 over 5. Does it reduce? Your calculator, if you divide it, will tell you 0.8. Folks, I want you to hear me loud and clear. You are not allowed to have a decimal for slope unless it's a word problem. Is this a word problem? So you're going to leave it as 4/5. Number 3, which point am I going to start at, the left or the right? The left, and there it is. How many do I have to rise? I don't want to rise at all. How many do I have to run? I think it's 5. Are we okay with 5? What is 0 over 5? It is 0. Folks, that thing is a horizontal line, isn't it? How much is it rising? What is the steepness? 0. It is not steep. A horizontal line has 0 slope. Do they both have a z in them? Yo, do they both have a z in them? Horizontal and 0. Yes, that's how I remember it. Horizontal lines have 0 slope. Make sense? Okay. Now, I don't have a graph for the next set of problems, do I? They're just points on there, aren't they? So if you do not have a graph and you just have points, you are going to calculate. You don't just get to count anymore. We have a formula. It is y2 minus y1 over x2 minus x1. Now, folks, I need to make some connections in this formula for you. So after you get it written, let's give me your eyeballs here. I mean, not physically give me your eyeballs, but look at me. All right, so here we go. Didn't we just talk about counting the rise over the run? Yeah. Folks, which variable rises and falls, the x's or the y's? Aren't the y's up and down? So it should make sense that your y's are in the numerator because the rise was in the numerator, wasn't it? Which variable talks about running left and right? The x, which is in the denominator, which is where the run was in the denominator, correct? Now, folks, I told you had to have 2 points, correct? So this little 2 and that little 1, that just means the second y minus the first y over the second x minus the first x. How is that for everybody? You're looking at me crazy eyes over there. Are you okay? Okay, so let's try it. So again, I don't have a graph anymore. I just have 2 random points. If I want to find the slope, I want you to label these x1, y1, x2, y2. Basically, I have a first point with an x and a y in it, and I have a second point with an x and a y in it. Then, I would like you to write your formula underneath that. And now, we're just going to plug in the numbers that you labeled. What is my y2? What is my y1? How's everybody doing with the numerator? Do you see why I labeled them in the first place? What is my x2? Minus the x1, which is, okay, folks, carefully, because I got negatives in there. Hold on a second. What is 7 minus a negative 3? 10. What's my denominator? 0. Folks, what is 10 over 0? Not 0. It's an error. It's an error because doesn't division mean to split things into groups? Like, for example, if I wanted to divide you guys into 2 groups, I'd split you into 2 groups, right? How do I take 10 and split it into 0 groups? You can't, because I'd have to make them disappear, and I can't. Okay? This is called undefined slope. Because, and you don't need to write this, but I want to show it to you. Maybe I should do it on here with the recording. Don't write this. If this is my graph, and I plot these points, please give me your eyes. Where would 6, negative 3 be? Where would I go for 6, negative 3? Over 6, down 3. Right about there, maybe? Where would I go for 6, comma 7? Which would be right about there, right? What kind of line is that? It's vertical. Isn't slope the steepness of a line? How steep is this? Too steep. It is too steep. Anybody ever seen Remember the Titans? Football movie, right? You've never seen Remember the Titans? Anyways, there's a scene in Remember the Titans where they go back and forth and they say too strong to each other. Back and forth. This thing is too steep. There is no number that I can say to this because it is so steep. That's why we call it undefined. This is the Valraven at Cedar Point. Right? Okay? Or the Steel Vengeance. The Steel Vengeance. Too steep. It is undefined. Are we clear on that? Okay. Let's look at the next one. Label your points, please. x1, y1, x2, y2. Write your formula down. Yes, you need to write it down. Let's plug in our numbers. What is the y2? minus y1 over x2. Okay, no. Negative 2 is my x2. Not plus 6. It's minus 6. Isn't that my formula? X2 minus x1. So what do I get my numerator, folks? What do I get my denominator? What is 0 divided by negative 8? It is 0. What kind of line is that with 0 slope? Zero slope is a horizontal line. So if I were to graph these points, it would make a what? Oh, nope, undefined's back here. That's if I have a 0 on the bottom. Does everybody see how the 0 is on the bottom there? Over here, the 0 is on the top, correct? 0 on the top is 0. It is a horizontal line. 0 on the bottom is undefined. It is a vertical line. Do you see the difference? Okay, let's try another one. Label your points, please. Hold on. I'm not done labeling my points. Writing down my formula. All right, now I'm ready. X or y2 minus y1. No. Just 4 minus 2. Over, what about my bottom? Negative 6 minus a negative 2. You have to be super careful with your minus signs, folks. What do I get in my numerator? Anybody else besides Savannah? Is 2 okay? Denominator. Folks, does 2 over negative 4 reduce? Put 2 over 4 in your calculator. 2 over 4. Can I have a decimal for slope? So what is 0.5? Everybody have their calculators? Clear them out, please. Please type in 2 over 4. I didn't say 2 divided by 4. 2 over 4 and press equals. It is 1/2. But this needs to be negative, doesn't it? So it is negative 1/2. Do you think that this line would be very steep? No, it's a half. Let's try one more before we move on. Label your points, please. How we doing plugging them in? Numerator is, denominator is, what is a whole 4? 8 over 2 is 4, isn't it? Yes. How steep do you think this line is? Well, this one was a half, right? This is going to be steeper, isn't it? How we doing, ladies and gentlemen? Kind of good. We're going to do some more. We're going to do some charts. I told you, if you're going to calculate slope, you have to have 2 points, correct? First of all, what in this problem tells me that I should be calculating slope? The directions. What do the directions say? Isn't rate of change slope? So I know I need to find slope. You have a formula for slope. Where am I going to find my points? In the table. Which points would you like to use? Is everybody good with me using these first 2 points? I'm just going to put parentheses around them and a comma between them like they're points. Then I'm going to label them. Hold on, I have x1, y1, x2, y2. Everybody follow, engage. Numerator is what? Denominator is what? What does this simplify to? Okay, that's the rate of change. But they tell me to explain the meaning. What are we talking about here? What are we doing? Y'all see the floor tiles on the floor right now? When I lay them, I gain area in what I lay. Okay, so that 16 is slope. Isn't slope rise over run? Change in y, which is up here, change in x, which is down here. What is the units on your y? What units are on your y? Inches squared per, what units are on your x's? Per tile. So what does this mean, folks? Every tile you lay is 16 inches squared. That's bigger than what you see on this floor. I believe these are 12 by 12 floor tiles. Okay. Everybody okay? Make sense? We got another chart. What are the directions telling me to find here? What is rate of change? Slope. You have a formula for slope. I must have 2 points. Where are they going to come from? Stop zoning out on me. The data table. Does it matter which 2 that I use? Which ones would you like to use? So I'm just going to make them look like points, nice and easy. Then I'm going to label them. And now you're going to tell me what my formula is. Well, give me what you actually did. Good. And you told me it's 76 over 2, which is what? 38. That's my slope, but I need to know what it means. What are the units on your y's? Because remember, the y's are on top. Miles per, what units are on your x's, which are on bottom? Hours. So what does this mean? Yeah, you're not getting anywhere fast, are you? Not really. 38 miles an hour. How do we feel about the charts? Better than 20, you're right. Everybody okay with the charts? We're doing good on time here. All right, let's go down to this graph. Now, folks, on the front, when there was a graph, we just counted rise over run, didn't we? Okay, can I simply count rise over run on this graph? Are they nice points? They are not nice points. So how can I count from this point up to that point when they're not nice points? We're going to subtract, because what formula are you using? What formula have you been using all day? Folks, aren't they saying, bless you, rate of change? What's rate of change? Slope. I need to have 2 points to do this, don't I? Can you tell me the 2 points for 2000 and 2002? What's the point that is associated with 2000? Why did I put the 2000 first? That's the x. Don't the x's come first in your points? X comma y, that's the x-axis. What is the point that goes with 2002? Okay, so now I'm going to label them. And aren't we right back to where we were before, folks? We have just been doing the same thing over and over and over again today, haven't we? It's just being asked to you a different way in a different format. So, what's my y2? Minus, over, minus, what's in my numerator? Bottoms 2, yep. How about that numerator? What is 7 over 2? It's 3.5, isn't it? Is it okay to have 3.5 as a slope? Yes, because it's a word problem. Awesome. Okay, well, I got a second part to this. Do you see how they asked me for 2002 to 2004? Got to do it again. What's the point associated with 2002? What's the point associated with 2004? I am going to label them. And we're going to use our formula. Hold on. All right. Hit me with it here. You guys keep up with Gage? He's right. Which is it okay to do 0.5 here, folks? Could you have left it as 1/2? Sure you can. Okay, now let's talk about this. What are my units for the y's? You guys see that, millions? What are the units on your x's? So this is 0.5 million per year. This is 3.5 million per year. Which one's better? Yeah, folks, look at your graph. Do you see this section right here? Do you see this section right here? Which one's steeper, the first one or the second one? The first one's steeper because it has a bigger slope. Isn't that number bigger than this number? That all should be connected for you. Doing okay? All right, we're going to skip that second graph. I don't think I need it. Let's go down to this chart. And I realized that that chart did not copy for you. I don't know. I'm not really sure. Can you guys copy in that chart, please? I don't know why it didn't copy. I apologize. Just make yourself a nice little T-chart, XY table. And fill them in. So, did everybody hear what Gage is saying? Do you see how he's kind of pairing those together? Because what is he trying to calculate? If they're linear, what is he calculating by finding 2 points? Guys, what have we found all day today? The slope. So Gage is going to find the slope 4 times. And I'm going to tell Gage to stop because I'm going to give him an easier way to do it. Did you hear me? Okay. So folks, if it's a line, it's linear, correct? Would you agree that if I make a whole bunch of points on this line, this slope better be the same as this slope, better be the same as that slope, otherwise it's going to be like jagged. Does that make sense? If the slopes are different, it's going to look like that. Wouldn't you agree? But I want all the slopes to be the same, don't I? Which means I want the rate of change to be the same, correct? Folks, I need to make sure that my x's and my y's are changing at the same rate. Are you ready? How much do my x's change? Oh, did we go up or down by 1? We went up 1. How about these x's? How about these x's? Up how many? Okay, you got, yeah, up 2. How about these x's? Does it look like the rate of change is staying the same? We better check the y's though too, okay? Yes, it is. How much is it changing here? Well, it's because you started while I was still explaining. How much do we change here? How about here? How about here? How about here? So folks, Did the rate of change stay the same for both the x's and the y's? No, that means this thing is non-linear. Come on, you got to admit that's faster than calculating all those slopes. Let's try the next one. What happened here? How about here? How about here? Everybody agree those are all -3s? Looking pretty good, right? How about over here? +5. How about here? How about here? How about here? Did the rate of change stay the same for the x's and the y's? So is it linear? Yes. You're going to cave in, Gage, and do it my way? Okay. How are we doing, ladies and gentlemen? Good? I am requiring you to label your points and write your formula. Are we clear on that? Okay. Your homework is that you will get started. This is what happens when I start letting you guys go to the bathroom once, then you want to go every day, and I'm not going to let you go every day. But you didn't get to go yesterday, so I'll let you go today. Okay. Yes.